Okay, so Preston, what's the learning goal today?
Solving equations with variables on each side.
Okay. So I can solve equations in one variable, so there's only going to still be one variable involved. It's either going to be all x's or all a's or all whatever the variable is, but that contain variable terms on both sides. Just like it happened when we were just doing this activity. There were x's on both sides of the equation, and you had to figure out how were you going to get it so it was just a 1x, and what was it equal to. So we are going to need to do just exactly what you were just doing. We need to get the variables on one side only. Okay, so one side, fill in the blanks. You can't have variables on both sides and get somewhere. You have to eventually get them so they're only on one side. And then you're going to solve the equations using the steps you learned previously. So hear me on this. If there are variables on both sides, variable terms on both sides, take care of those variable terms first. Okay? Take care of that first. Do not worry about the constants. Take care of the variable terms first, and then it'll be hopefully a little bit easier to follow the previous steps that we were doing before. Okay? So let's look at our first one here. 4x plus 5 equals 2x plus 9. We could have done that if we would have had enough students, but we didn't have enough students to fill all the spots for it, so we're going to do it algebraically. So we have 4 x's on one side, and we have 2 x's on the other side. We need to get it so that we don't have x's on both sides. What do you think we could do here?
Minus 2 on each side.
Minus 2x from both sides. Yeah, we're going to subtract 2x from both sides. We're going to, just like we were doing when it was you guys holding the cards, take 2 x's away from each side. So whatever we're doing it to both sides here. And after those 2x left, on this left side, what do we have?
2x plus 5.
We have 2x plus 5. Well, I won't recognize by black pen here. And what happened to these x's? Are there any left on the right side? No, they took care of each other. They're both gone. So we have 9 left on that right side. Okay, now it should look like a familiar equation to you. Now it should be like, oh, I know what to do next. What do we do? Samuel? Samuel? Do what? Yeah, subtract 5, minus 5 from both sides. Take 5 away from both sides. Do you have none of a pencil, Holly, or what's up? Already done solving it?
Yeah.
Oh, goodness sakes, I'm going to have you come up here and teach today. What's the solution, Ollie?
The answer?
Well, that's the solution, yeah?
2.
2?
X
X equals 2? Okay, let's see if we can agree with her, since she's speedier than us. 2x equals 4. And what are we going to do next? No. We're not going to divide 2 by both sides. We're going to say it correctly. We are not going to divide 2 by both sides. We are going to divide both sides by 2. There's a difference. Wait a minute. 5 divided by 10 is not the same as 10 divided by 5. We have to say it correctly. So we're going to take the 2x, that side, and divide it by 2. We're going to take the 4, the other side, and divide it by 2. We're going to divide both sides by 2. And we are going to get x equals 2. Okay, good job. Just, not only can we get right answers, but we can speak like we are, our math geniuses too. Okay, anybody have any questions? No. Okay, well, not always are there going to be positive terms and just addition going on in problems. In fact, the next one, what's different about this one that is different totally from the 2 we practiced with the cards, with you guys being the parts of the equation, and this first one that we solved here? What's different about this one? There's a negative variable term. What else? Isn't it missing something on the right side? It's missing a constant on the right side. So these get tricky because we want to sometimes, it doesn't matter, by the way, which side we get rid of the variable term on, but if we get rid of it on the side that doesn't have a constant, what people do is they sometimes move the equal sign over, and they can't move it over. They should be putting a 0 there on that side instead. So what I'm going to suggest we do is I'm going to suggest that if we have a side that does, like the right side of this one, does not have a constant, we move the variables that are on the side that does have a constant. So what should we do? We should subtract 3y. We're going to work on the side that has the constant, not the side that doesn't. Let's just decide right away that if the one that doesn't have a constant, we're going to leave that one alone, and we're going to take care of getting rid of them on the other side. So we have to subtract 3y from both sides. Well, remember when we are subtracting and we have negatives involved, what are we going to do with our subtraction? Add the opposite. So we're going to change that addition to our subtraction to addition, and we're going to make that a negative 3. So that without our calculator, we can say how many y's do we have now? Negative 5. Yeah, we have a negative 5. Negative 2 plus negative 3 is negative 5y. So that's what we have on the right side of our equation. And what do we have left on the left side? 20. Okay. So what's our next move? Divide both sides by negative 5. Good job saying it. So 20 divided by negative 5 and negative 5y divided by negative 5. And we get a negative 4. That's right, because a negative or positive divided by a negative is a negative, and there are 4 5's in 20. And we have just y by itself now. Y equals negative 4. So the only thing really different today, we're still solving equations that contain more than one operation in them. But what's different today is what? What's different today? What got changed out from what we were doing last week? We have variable terms on both sides. Before we've only had them on the one side. We either had them on the right or we had them on the left, but today we have them on both sides. Okay, let's go to the back side. I think we're only going to practice one more. But before we start this one, before you even make a decision about what you're going to do, I see a subtraction in it. So what do we do? We're going to add the opposite. So we're going to rewrite this as 4a what?
No.
What? You want something that you want to ask a question about, or you think it should be something else? Okay. 4a stays 4a because it's not what's being subtracted. It's the 7 that's being subtracted, so we change the subtraction to addition, and the opposite of 7 is negative 7. And do we need to change anything on the other side?
No.
No, we already have addition, so we don't need to mess with it. Okay. Make a decision. What do you think would be a good move? First of all, there's constants, there's variable terms on both sides and constants on both sides, right? So our first move is going to be which variable term do I want to get rid of? Do I want to get rid of them on the right, left side, or on the right side? Right side? Okay, why on the right side? Because you like the variable to end up on the left? Okay, that's one way we can do it. If you prefer the variable to end up on the left, you can do that. What's another option we have? Can we get them off? Can we get rid of them on the left side? We can. Now, here's what happens. I want to just, you get to make the choice. Everybody gets to make their own choice on this. Holly says she wants to get rid of them on the right side because then she'll have variables on the left side where she likes them. I say I want to get rid of them on the left side because then I'm not going to have to deal with a negative number when I do my moving. So you get to make the call. Okay? So basically what I'm saying here is I'm going to show you there are 2 different ways that we could go about starting this one. Holly's way says, I want to get rid of them on the right side. So what are we going to do, Holly? Minus 8a. Okay? So we're going to subtract 8a from both sides. Well, over here, that the goal was to get rid of them. So we end up with equals 9. And over here, probably should change that subtraction to add the opposite so that we can get a good answer. 4 plus negative 8. Negative 4. So we end up with a negative 4a plus negative 7. Okay, that's doing it that way. I want you to, in your notes, I want you to do it both ways, okay? I want everybody to do it both ways, even though you may have, you're going to have a preferred way, probably, but let's everybody show that you actually have options. You may not do it like your friend is doing it, but you both get the same answer, okay? So if we do it this one, and I say I want to do the, get rid of them on this side instead, I'm going to subtract 4a from both sides. And I'm eliminating them on this side instead. And now I have a negative 7 left over there. And what's 8a take away 4a? 4a. Okay, so we'll do both ways and we'll just see what happens, okay? So here's what I was saying. If we do it Holly's way, we end up with a negative number of a's, which is totally fine, you can. If we do it my way, we end up with a positive number of a's. So it doesn't matter. Just depends on what you like to work with better, okay? So in this one, let's go back to this side. What are we going to do to get that negative 7 out of there? Add its opposite, add 7, yeah. We're going to add 7 to both sides. And we're going to end up with bringing just our negative 4a down, because these guys take care of each other. And what's 9 plus 7? 16. Let's go ahead and finish this one. See what our answer is over here. Negative 4a divided by negative 4. Is that the right move? And 16 divided by negative 4. What do we end up with? A equals negative 4. A positive 16 divided by a negative 4 gives us negative 4. Okay, now let's finish this one. Should we get the same answer? We better, yeah. Okay, what should we do? No, we want the a's alone. Well, let's subtract 9 instead. Okay, so again, I want both of these ways in your notes. You don't have to do it 2 ways in your homework, just I want you to see that you have a couple of options sometimes. So let's change this to add the opposite. What's a negative 7 plus a negative 9?
Negative 16.
Negative 16. And what happens over here? These guys cancel and we have 4a, not just a yet.
Divide both sides by.
And now we divide both sides by 4. So we have negative 16 divided by 4 and 4a divided by 4. And what's a negative divided by a positive? Negative 16 divided by 4. So we get a negative 4. And over here we get a. We get the same answer. Just read. This one, these two can trade places, and it's really exactly the same thing. So let's just do a quick run through of what are we going to look for. If there are variable terms on both sides, what's the next thing we're going to look for before we decide which side we should get rid of the variable term on? What else do we want to look for besides variable terms on both sides? Go back and look at the second problem for practice. What was missing in that one? Well, negative numbers isn't necessarily the problem, it's the, what's missing? On one of the sides, what's missing? The constant. So if we don't have a variable term and a constant on both sides, one of the sides is missing a constant, which side are we going to move the variable from? Look at number 2 and see, what side did we do it from? The side that had the constant or the side that was without the constant? With the constant. We're going to move the one that And then we can solve from there. If they have, both sides have the constants, then it doesn't matter which side that you decide to take the variable term away from. Get rid of it on, okay? Okay, so let's get out a sheet of loose leaf paper to write down. We only have, looks like, about 7 problems to do. No, there's 7 actually. I think when you count them up, you'll find out that I'm right.